All right, welcome back. Now we're going to be talking about some logical statements. So these are if statements, else statements, and loops. So Boolean expressions, much like Boolean uh, types, are either true or false. Boolean expressions are made up of different Boolean values and are evaluated throughout the whole thing to be true or false. And Booleans and Boolean expressions are how you control the flow of your program. Maybe you only want one line of code to be executed if certain conditions are met, sort of thing, or you want to run through and do something repeatedly with a loop. And how you do that is using Booleans. So, Boolean operators are how we create our Boolean expressions. Not is the negation. So, it switches the value from false to true or true to false, and evaluates two sides of a statement and make sure that they have to both be true for it to work, or evaluates two sides and either one can be true. Double equals is equivalency. So we mentioned in an earlier lecture how a single equals sign is assignment, doubles equals is equivalency. A exclamation mark and an equal sign is not equivalent, so checking if two values aren't equal. So 4 is not equivalent to 5, sort of thing. Then there's strictly less than, strictly greater than, less than or equal to, greater than or equal to. All things you've likely seen when you were in school. Maybe you drew some crocodile eyes over the greater than or less than signs to say it's eating the hungrier one. Um, so building Boolean expressions. They're built with Boolean operators, as I said earlier. So like the and needs to be true and true, which would evaluate to true because both sides are true. True and false would evaluate to false because one side is false. They both need to be true. False and false would evaluate to be false. So I know that's kind of confusing because they are both the same value, but they are both the same value of being false. So it's still false. Or statements, only one needs to be true. So true or true would be true. True or false would be true because only one side needs to be true. False or false would, again, be false. Then the equivalency, if this is equal to that, if they are the same object or same value, then that's true. As I've said, two equal signs is equivalency. This doesn't equal that. Make sure things are different. So 4 double equals 4 is true. 4 not equals 4 is false because 4 is equivalent to 4. So think back to school. Maybe you drew your crocodile eyes. 4 is less than 5, which is true. 5 is less than 4 is false. 4 doesn't equal 5 is true. And 4 equals 5 is false. So you can use parentheses to create more complicated Boolean expressions, and you can combine them into even longer ones. So we have 3 Boolean expressions here. We have the 4 less than 5, the 6 greater than 7, and the 4 less than 5 and 6 greater than 7. So 3 total. That would be false because while 4 is less than equal to 5, or less than 5, 6 is not strictly greater than 7. You can make these as intensive as you want. Just make sure to nest properly with your parentheses. Typically, you aren't going to do these just checking 4 less than 5. You'll compare variables or the length of something or if certain other conditions have been met. Yeah. So control flow. Boolean expressions are used to determine its Boolean value, and if true, you execute a block of code. Key words for this are if, elif, shorthand for else if, and else, to control which block of code is run. in your subsection. We'll do examples here in a sec. If statements can be standalone, elif or else statements must always have at least one if preceding it. There can be as many elif statements after an if as you would like in a block, and however, there can only be one or zero else statements, up to one else statements following it. Else is the default statement, so you can't have multiple defaults. So an example of an if statement is if your Boolean condition, code block to be executed, elif Boolean condition, code block to be executed, else code block. So only one of these code blocks will be executed. If the if condition is met, see, I'm using control statements in my language. If the if condition is met, the elif and the else won't be executed. If the elif condition is met, the if won't be executed and the else won't be executed. If neither the if or the elif are met, then the else will be executed. As I said, you can have as many or as few elifs as you would like, and you can have less than or equal to one else statements. So when you have multiple if statements in a row, though, any number of those can be fulfilled. So both of those if statements, even though they're back to back, might be fulfilled and they could be executed then. So combining if statements with Boolean expressions. The Boolean expression in an if statement can be written however you want it to be. So for example, if 4 less than 5, which is true, so the inner block of code is executed. Typically, instead of static numbers, variables are compared or other aspects. So we can go through here and look. So let's take a look at it first. So if 4 is less than 5, 4 is less than 5, so that's true. If 4 is less than 6, that's also true, or the default. However, because the if statement is met, this elif will not be executed. So we can go in here and then in the first statement. So what if we do instead if 7 less than 5, and then we're just gonna say if 7 less than 6. No condition met. We make it to our else statement. So even though, both the if and the elif were true initially, only the if is executed. However, if we have if statements bundled up together, all three of those are going to be good to go because they don't have the else or the L preceding it to dictate that only one can be executed at a time. So looping. Looping allows a subset of a code to be repeated any number of times based on a condition. It evaluates Boolean expressions still to determine if the loop should continue. It avoids having to rewrite lines of code to accomplish the same task repeatedly. So it's kind of like a function in that regard, whereas functions can execute the same block of code repeatedly at various points throughout a program. A loop will do the same execution all together at once in the same block. So we'll talk about while loops first. So it evaluates a condition and executes the code within while that condition is still true. So while condition, tab, code block. If you want to use a variable per se, you must declare it prior to the loop. This is different than for loop. So we have like while x is less than 100. For the example, we're only going to do 10, but we need to have x declared beforehand. If we don't have x declared beforehand, this won't work. So all this is going to do is it's going to print out x and increment x by 1, 0, 1, 2, 3. So so in programming in Python, and most languages, some are different, but we always start counting at 0. We'll talk about that more when we get to lists, why. But so while x is less than 10, we're going to print out what x is, and then x is equal to x plus 1, just explicitly showing that we're incrementing x by 1. For loops they make repeating over an interval easier, just in that we don't have to declare our variable beforehand. So for I in range of 5, print I. This is essentially going to do the same thing as we did above, but a little cleaner. So as you can see, we still get 0, 1, 2, 3, 4. The in range is still less than, excuse me, not less than or equal to 5. Strictly less than 5. Nope. Try 2. Tilde for code block. It's just strictly less than 5. It doesn't equal 5. So if you want it to include 5, you'll have to do in range 6. Okay. So for each loops are the final loop we're going to talk about. They go through each element in something, so like a list or a string, etc. So if we have a list, let's say cities, and we have Laramie, Pinedale, Cheyenne, Casper, Jackson Hole, Sheridan, just a list of cities in Wyoming. We can do for each city in cities, we'll print the city, which will go through every element. And as we can see, we have cities declared, and then it prints them all out. We can do the same thing with strings. So we can say for C in Y stack, tab, print C. And, oh, my bad. There we go. Prints it all out. Good to go. Yeah, looping and if statements are pretty much what every program is built upon.